Good morning, our listeners, and welcome to today's class. We are still considering problems that revolve around logarithms. In our previous class, we looked at a system of equation, which, after transforming it, led us into a simultaneous equation. But today, we are looking at situations where log of a number is defined in terms of letter x, log of another number 3 defined in terms of a letter y. And we are given a log problem and asked to evaluate it in terms of x and y. So the major effort here is how to transform this equation such that it will involve log 2 and equally involve log 3. Another thing we need to bear in mind is that when a log of number is written without considering the base, naturally we treat it to be in base 10. So one can easily say that this is log 2 base 10 equals x and log 3 base 10 equals y. So first of all, we consider the problem and see whether we can transform it to involve log of 2 in base 10 and involve log of 3 in base 10. And the problem we are given is this. We have log of root of 1 over 72 base 27. Now we are talking about in base 10 and in base 10. And if you look at what we have here, we are having base 27. So there is a need to consider a change of a base in this problem. And of course, in logarithm, we know that whenever we have something like this, that log of capital N base A, and we want to change this base from A into something else, that this can be expressed as this. This equals log of capital N in base C all over log of A in base C. So we are no longer discussing base in A, we are discussing base in C, where we are treating this number here as a number here, and equally treating this base here as a number here. So using this approach, I can transform this such that it will involve base 10 to enable me treat this thing in base 10 and equally treat this one in base 10. And by doing so, I will come back to this problem, and this problem becomes log of square root of 1 over 72 in base 27 equals log of square root of 1 over 72 in base 10 all over log of what? 7 in base 10. We are no longer discussing base 27. Instead, we are now discussing base 10, where we are treating 1 over square root of 1 over 72 as a number and equally treating this 27 as a number. Of course, you and I know that this thing can be expressed this way, that this equals log 1 over 72 in base 10 all raised to power 1 over 2 all over log of 27 in base 10. Of course, when we have this in this way, we are told in logarithm that whenever a number is raised to a power, that we use that power to multiply the entire logarithm. Therefore, this problem can be written as b equals 1 over 2, which is the power I have here, log of base 10, 1 over 72. All over. What I have here is what? Log of 27 in base 10. Of course, we are making an effort to see whether we will be able to transform this problem in such a way that it connects log 2 base 10 and connects log 3 base 10 to enable us to use the letters x and y while evaluating the answer. So we intend to break down this 72 into its index form to see whether we are going to get a value 2 and 3. And let us consider 72. If you consider 72, you have that this and this is 72. I am going to look for a number that can go into 72 without remainder apart from 1. And that number is 2. So I have 2 here. 72 divided by 2 will give me 36. I will equally look for a number that can go into a smallest number that can go into 36, and that number still remains what? 2. 36 divided by 2 is what? 18. I still equally look for a small number that can go into 18 without a remainder, and that number still remains 2. And then 18 divided by 2 is what? 9. 2 can't go again. We now go to the next number, and that next number is what? 3. Fortunately, 3 can go into 9. I will now write what? 3 here. 9 divided by 3 is what? 3. I will equally retain the same number 3 because 3 can go into 3. So I have 3 here, and 3 divided by 3 is what? 1. So in that case, I can express 72 to be that 72 equals 2 times 2 times 2 times 3 times 3. And of course, 2 times 2 times 2 times 2 equals 2 raised to power 3 multiplied by 3 raised to power 2. So I am now seeing that I'm having something 2 here and I'm having something here 3. So we are going somewhere. So what I'm going to do, wherever place I see in this problem, 72, I will replace it with 2 raised to power 3 multiplied by 3 raised to power 2. And on that note, this problem becomes, this equals 1 over what? 2 log in base 10 of 1, which is this one that is here, all over. Rather than writing this 72, I am going to write 2 raised to power 3 times 3 raised to power 2 in each place. It becomes 2 raised to power 3 multiplied by 3 raised to power 2 all over log of 27. But rather than writing 27, of course you know that this 27 can be expressed into 3 times 3 times 3, which is 3 raised to power 3 all in base 10. Now, this thing equally can be expressed as this 1 over 2, which is what I have here. Then we have log, and we open a bracket. What I have here is 1 all over 2 raised to power 3. So I have 1 all over 2 raised to power 3 multiplied by. What I have here is 1 all over 2, 3 raised to power 2. 1 all over 3 raised to power 2. Close the bracket. All over. I have log of 3 raised to power 3 in base 10. Yes, of course, we remember a law in logarithm that says that multiplication is addition. So I am going to apply that law here, that instead of having multiplication here, I will be able to end up going to have addition. And by that application, this problem becomes, this equals, here still retains 1 over what? 2. We now have log. This thing now is coming in here, so I have log of 1 all over 2 raised to power 3 in base 10. I am no longer going to consider multiplication because multiplication in logarithm is addition, so I'm going to use plus. I have plus. I have log of what? 1 all over 3 raised to power 2 in base 10. I will now open and close because this 1 over 2 is going into all of them. Then I have all over. Here I have, but like I said before, this number is raised to power 3, so I can use this 3 to multiply the entire log. And it becomes what? 3 log of what? 3 in base 10. Okay? Then we progress further. By progressing further, permit me to clean this side. By progressing further, what I'm going to do here, of course, you know that whenever you have something like 1 over 2 raised to power 3, that this thing can be written as 2 raised to power minus 3. And wherever place you have 1 over 3 raised to power 2, it can equally be written as 3 raised to power minus 2. So what I'm going to do is that in place of 1 over 2 raised to power 3, I am going to use 2 raised to power minus 3. And in place of 1 over 3 raised to power 2, I am going to use 3 raised to power minus 2. And by so doing, what I'm going to have here now becomes d equals 1 all over what? 2, open a bracket. I will come here, I'll write log. Rather than writing 1 over 2 raised to power 3, I am going to write what? 2 raised to power minus 3, then base 10. I am done with this. The sign here is plus, then I have what? Plus. I come over here. Then I'll have log. Instead of writing 1 over 3 raised to power 2, I am going to write 3 raised to power minus what? 2 in base 10, close the bracket, all over. I have 3 log of 3 base 10. Okay? So I will now clean this side. So what I'm going to do now is, I am seeing log of 2 base 10 here. I'm seeing log of 3 base 10 here. This is a power. I can use that power to multiply the entire log. This is power. I can use that power to multiply the entire log. And by doing so, this problem becomes, this equals, I have 1 over what? 2, open a bracket. Then in place of this thing, I have the power to be minus 3. So that minus 3 comes down to multiply the entire log. I have minus 3 multiplied by, I have now log of what? I have 2 base 10. The power here is minus 2, and that minus 2 comes here and affects this positive sign to become minus. So I have minus what? 2 log of 3 base 10. Close the bracket. All over. I have 3 log of 3 base 10. I am glad now. Glad in the sense that we are given that log 2 base 10 is x, and I have log 2 base 10 here. We are given that log 3 base 10 is what? Y, and I have log 3 base 10 here. I have log 3 base 10 here. What am I going to do? Wherever place I see log 2 base 10, I'm going to use x. Wherever place I see log 3 base 10, I am going to use y. And this equation then simplifies out into, this equals 1 all over what? 2, open a bracket. Here I have minus 3. The whole of this thing has become what? X. So I have multiplied by what? X. The sign here is what? Minus. What I have here is what? 2. Then the whole of this one now has become what? Y. So I have multiplied by y. Then I will close the bracket all over. Here is what? 3. And the whole of this thing has become y. So multiply by y. So of course, when I have something like this, it's just like this one is multiplying the entire numerator, and this 2 is multiplying the entire denominator. And what I have here becomes minus 3 times x is what? Minus what? 3. Here is what? Minus 2 times y is, this is minus 3x. That's minus 3 times x minus 3x. The sign here is what? Minus 2 times y is what? 2y all over. What I have done is to consider the numerator, because if 1 goes into the numerator, it still retains the same value. So I'll come here, this 2 here goes into the denominator, and if it goes into here, it becomes 6y. And by this, we have arrived at the final value of the answer to the problem of number 1, where we are told to find the value of log of root of 1 over 72 base 7 in terms of x and y. What we have here is x, what we have here is y, what we have here is y. They can ask you this for a question further by giving you specific values of x and y and asking you to evaluate. And once you do, you still arrive at the same answer. We want to believe that you enjoyed this number we have provided a solution to. So we are going to go over to number 2. Situation whereby you have anything confusing to you, we encourage you to drop your question in the comment section, and help us equally to like, follow, share, and subscribe as we embark on this journey. Thanks for listening as I take you over to number 2. Okay, number 2 says, if log 10 base 8 equals x, evaluate log 5 base 8 in terms of x. So as very close to what we did before, we are going to transform log 5 base 8 into something similar to log 10 base 8 to enable us use the value of this x to evaluate this in terms of x. And I'll first of all write this one to be, the question we are given is log of 5 base 8. And of course, you know that there's no difference between 5 and 10 all over 2. So I can decide to use in place of 5, 10 all over 2, and still retains the same problem. So this thing can be expressed to be, this equals log of 10 base 2. So log of 10 over 2 base 8. So I've expressed this in terms of these. Then I'll go further and remind us about the law of division that says that division is what? Subtraction. So whenever numbers divide, of course, you express them in logs by considering subtraction. So this thing equally can be expressed as, I will now say, but log of 10 over 2 base 8 equals log of 10 base 8 minus log of 2 base 8. What I have done is to consider the law of division that calls it subtraction. Now, looking at this, I have now log 10 base 8, and log 10 base 8 is given to me here to be x. So I will now, in place of this, I will put x. And this problem becomes what? X minus log of 2 base 8. Yeah, we are not going to leave this one this way. What we are going to do is to see whether we can simplify it further. By simplifying it further is this 8 that is here can be written as 2 raised to power 3. And then this problem becomes x minus log of what? 2 base 2 raised to power 3. And we are told in logarithm that whenever the base is raised to a power, that we use the reciprocal of the power to multiply the entire log. And then what we now have becomes this equals x minus. The reciprocal of 3 is 1 over 3, so I have 1 over what? 3 log of 2 base 2. And of course, another thing we need to note is that the log of a number to its base is 1. So this log 2 base 2 becomes 1, and then this equation simplifies out to become x minus 1 over 3 multiplied by 1. And of course, 1 multiplying anything still remains that thing, and then the answer finally becomes x minus 1 over 3. We have expressed this log 5 base 8 in terms of x, given that log 10 base 8 is x. We equally want to believe most sincerely that we must have simplified this problem in a way and manner that you gave it understanding, and we encourage you to still follow us, still comment, still share, still subscribe as we continue to be bringing to you mathematics in a very simplified form and format. Thank you very much for your audience today. Thank you very much for following us. Thank you very much for commenting on the comment section on our different social media handles. Thank you very much.